Yeah, so welcome to the meeting today. Really happy to see a few of you guys being really interested in this game development course. Really feel appreciated for that. Yeah, so just to give a brief recap, in the previous lectures, like in the last lecture, basically, I asked you guys to develop a character. Like in the few previous weeks of this lectures, I asked you to design your own character. Now, in the previous week, you want to implement that thing that you designed and drew, and basically on whatever wherever you drew it, I wanted you to implement that in Unity, and essentially, just develop that character and put it in the maze game, right? And this is actually training you guys on how to, put all your ideas together. It's kind of a brain exercise on how to, implement things, organize things in your workspace and stuff. It was really great. I even saw the results. I was really impressed from most of you. I also was really amazed that one person was doing using the Pro Builder tool. And I just want to like clear it out, guys. You don't have to use Pro Builder tool necessarily right now. I haven't taught you that yet. I'm pretty sure on the fourth project I'll be teaching about Pro Builders. So in the meantime, if you feel like, hey, I just don't get this at all, this Pro Builder stuff, don't worry because I didn't really teach you that. Then just use the normal Unity tools, like which is the normal shape tools, like the squares, the cubes, the spheres. Just use the basic shapes and just start making anything out of it, right? And that's the purpose of Unity. It's very versatile, and you could do whatever you want to do with it. All right. So, okay, just to give you a brief recap, I'm not so impressed by you guys because I did not make my own maze. So, in today's lecture, what we'll do is I'll introduce guys to prefabs because in the previous class I was just talking very briefly in abstract terms about what prefabs are. But prefabs are actually really important. Okay, prefabs are super important in Unity, and I really want to go over it so that you guys can ace that kind of content and really appreciate what Unity really is, what they really offer to you. And then what we'll move on from that is we're going to introduce ourselves to what specific components, as I mentioned, that there are many tools that Unity offers, and you could put them on these individual objects. And we call these individual tools called components. Okay, each different components are responsible for different things. There are things like transform, right? We were dealing with. Let me just give you an example. Let's go to the main chat. Like for example, in this Unity, you can see that if I click on a cube, we were dealing with all these things over here. We were changing the rotations, the positions, the scaling. This is a specific component, right? Then this is also another type of component. This is another type of component, like cube, mesh filter, mesh renderer, probes, box collider. We haven't gone through these yet, but you should kind of get a brief, like some sort of idea in your head that all these things are components, and these are like tools that Unity has already built in. Like it's built-in features in Unity, and you can use them and utilize them in a really wise manner to make amazing games, right? So if, let's say for example I change the x value, well, I'm changing the x coordinate of whatever I selected, which was the ground. I don't know why I called it cube. I just called it. I was supposed to call it ground. So let's just click on that. Just guys, make sure that whenever you are making your games, make sure you do name things, all these different objects you made, in a really appropriate manner. I'm not gonna grade you on this. Obviously, nothing is graded here, but it's just like a good practice that I recommend for all of you to perform, like do. And from doing that, it's just gonna help you keep yourself organized. And whenever you need to come back to your game to add patches and bug fixes, you can easily understand things. Okay, it's just like a built-in foundation that you just made from the beginning, and it's just helping you in future so that you don't get so super confused when you're coming back to this project after like 5 or 10 years, right? Who knows? So that's my idea about what components are. And what we will do today is we will learn about this new component. And just let's just kind of spoil it a bit. If I click on add, this is like a place where you can add more components. They have a lot. Like over here, this is like a list of them, and you can select as much as you want. Obviously, we won't be using AR right now because we're not into augmented reality or virtual reality. That's a whole new chapter. But yeah, once we start getting a base foundation knowledge of what Unity is and how to use it, we can start moving on to AR and VR, which is again really fun because I've started making some games from there. So let's say I just type rigid body. You see that there are two types of rigid body, which is rigid body like just in general, and then the rigid body 2D. For this course, the GDC course, we are ignoring 2D game development, and rigid body 2D just exists because Unity has made separate kind. They had made two different types of rigid body components. One specifically for 3D game development and one for 2D game development. The rigid body that has nothing after that, that is for 3D, and we'll just stick with that. So if I click on that, there's actually a lot of features that come in, and we will go over it today and really, get to understand this as much as possible. Because right now, if you're looking at it, you're like, oh my god, like what am I even looking at? So yeah, let's just go over it after we introduce ourselves to prefabs, and then I'll talk about what if-else statements are. These are just like conditions and stuff. And it's really important because if-else statements, it really becomes helpful when you're trying to bring condition statements inside of your program. Like, hey, you can only perform some specific type of statements if some condition is met, and it's really helpful if you're trying to distinguish between two scenarios in the games. And you'll really get that. It's pretty much self-explanatory the moment I teach you what if-else statements are. Pretty sure a lot of you guys might have already known in a way what if-else statements are. You probably played with Scratch, or you probably played with Python, or maybe even Java. Java is also really famous for if-else statements. So yeah, we'll just go over it very briefly. Maybe not briefly, a bit more than usual. You want to kind of get a good, solid base foundation of that knowledge as well, because it's really important to know that when we're going to start making more video games in the future. Right, and then we're going to finalize, okay? The biggest thing that I want to do, the goal of today's meeting agenda, is to be able to make this sprite move forward, backwards, forward, back. Basically be able to move this without making myself manually move this, okay? Right now we're in the scene mode, right? But if I play this game, right, I'm expecting myself to be able to move this this object over here. Okay, so if I'm playing this right now, this is the game view. Like literally, I'm not seeing anything right now. And if I press any buttons, well, it's not pressing anything, right? Because in the last lecture, recently, the most recent things we did in coding is just make these debug logs, which is just helpful to see the bugs in the game. But we're not actually moving the character itself, which is the real point of making a game, right? You want to see that thing happening on screen, not on some console, right? That would be just boring. Okay. So we'll make sure that happens today. And just to be clear, you might be confused that, okay, if you move the character, then the camera must move, right? Well, we'll go over that in the next lecture because that's, again, a whole new thing to talk about because Unity has an amazing tool to provide us with when working on this stuff, all right? Yeah, and then I'll just, brief you out with some assignments. I haven't made the assignment lists yet, but I will soon post it out on the GDC server, and you can look it up on your same time. All right, and before anything happens, just make sure next week, October 15th, is the date I'll be announcing the winner of who will be getting the Discord Nitro for free. And to do that, just be on first place on the Me6 leaderboard. You can always check that, and I don't know why people love to use bot commands, but just to give you a brief insight, you can actually just go to leaderboard over here, which is in the reward game, and if you click on this link, it should just direct you to the place itself, the leaderboard, as you can see over here. Right now, I think Oli's the first place, so congrats to Oli. But don't be super overconfident right now, because IQ could be on his way to win, Charville could be on his way to win, so keep yourself working. And ways to earn XP could be like, hey, you got to type more on the server, be more active. Or, another cool way, which a lot of you guys don't know, is every night, the day before I'm over with the day, right, I would be giving XP to those who have bumped the server. Okay, and you get 300 XP per every successful bump. Now, if you get this message where it's error, I'm not going to give you a bump. It has to be successful, and then I'll be giving you a bump there. All right, and then the final way is, again, I believe that we have also made some updates to the Instagram bot, so now you will no longer see the Tesla bot, so RIP to that guy there. I'm really sorry. But what you can do is you can also earn a lot of XP, like around 1,500 XP, per every mention of our Instagram post. And the moment you mention our name in your Instagram story, we're instantly going to give you 1,500 XP. So that's also another way to get your things rolling in, right? And then obviously submit your assignments. So every assignment submission that you do, any list of a specific assignment, each list that you complete, you will get 1,500 XP. So just keep on doing more assignments. Keep on working hard. I know you guys are diligent. You guys are working hard. You're doing your best. Keep on asking questions on Unity. You'll also boost up your XPs there as well. All right. Let me just check the Unity text. Oh, is the video very low quality? Oh, my bad. It's okay. I'm really sorry about that. All right, but actually, let's move on to talking about our course today, right? So, where do we start? We start from prefabs, okay? What I'm going to do is I'm going to give you like the scenario to explain prefab. It's not like a lecture where I can just give you some explanation. It's like, wow, I know it now. I know a lot of us do not like to hear a lot, do not like to read a lot from the slides. I kind of see that personally. I just don't like doing that either. I don't like reading it a lot, but rather being more kinetic, right? Being more moving on with my Unity application, being more hands-on. That's a better word. And we're going to learn that way, okay? But before we do anything, we just want to know like some words about prefabs so we can get a better understanding of what it is. Okay, so let me just go back. Let me go to the present mode. Yeah, present mode. Uh, Hopefully, I'm also planning to end the meeting by 3:45 p.m. so that, yeah, it's not gonna be taking much of our time. Right? Oh, I think this is a slide 2 ahead. All right. Sorry if the thing is glitching a lot. My apologies. All right, so let's talk about prefabs. Prefabs are basically like templates. Just think of it like a template. Like let's say from now on, we have already made this land, this character. But what if now we want to access like this specific character in other levels? Now, I think you've seen this in my previous project, like in the previous lecture, that I've already made prefabs. Like, how do you even know that something is already prefab, right? Well, the way to know that is it's always the color. If it's blue color and it shows up this kind of specific type of symbol icon, just keep yourself in the head. Keep that always in your head that, okay, that is a prefab. This, anything that's grayed out, like something whited out or something like this, if it's just not filled in with blue, basically, this cube, if it's not filled in with blue, then that's not a prefab. And that's just giving you like a ding, 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 that's not a prefab yet, and you need to make it a prefab. Now, one question, how do you even make a prefab? I actually don't know why. Oh, I made a script test. Okay, my bad. One way you can make a prefab is by just dragging it over here to the ground. That's the best way to make a prefab. I don't think there is another way to make a prefab. I think you can right click and make it. But honestly, to learn from me, to save time, just drag it down here to the project file here, the place where you store all your folders and stuff, your assets. And that becomes a prefab. And you can see that over here at these things are prefab. Now you're wondering, what now? Okay, like we made a prefab and stuff, but what do we do now? Let me save it because it was start. Now let's say I made another scene, okay? Like let's say I made another scene, so I create and where is my scene? Where's the scene thing? This is very sus. I'm trying to find scene. Guys, can you see scene? Or am I just blind? Oh, okay. Wow, I was blind. Okay. My bad, guys. And let's just say I made a scene, and maybe this is level 3 scene, okay? And I go to that scene. It's empty. But let's say I want to put the character in there. I don't want to control C and control V that. Okay? Even if I do that, like let's say I save it. I don't think you still can, but let me just try. If I right click. If I right click and copy. And I paste it over here. Oops. Over here. Let's say that this wasn't prefab before. Let's say it wasn't. Yeah, it exists. But if it was prefab, like let's say the thing that we just prefab, just think of it as and this object right over here, the thing that we just copied from the previous place. Now the thing is, if we wanted to apply a change to every single levels, because we made some, hey, we forgot to add the googly eyes or some ear thing or some additional feature on this character. What happens is if you haven't prefab this, you're gonna have to individually go to each level, right? If I save this, I have to individually go to each level and make the change. Whereas if I actually just used prefabs in the first place, I can actually go where the prefab is and just apply the change in that. So let's just say I wanted to add a new object. So let's just say another cube, okay? And we just added it on top. And let's maybe give it a color of maybe a brown color, something like that. Let's give it a hat, okay? I don't know if that looks like a hat to us, but okay. Now you can see that it's applied here. Cool. And if I go to level 3, oh, whoa, it's actually also applied here as well. And let's go to level 1. Yeah, it's also applied there as well. So you can see that idea that prefabs is actually saving your time. And this is something that you guys need to keep up, that even though there are many ways to do things, you should do things the most effective and efficient way possible. Because the biggest thing that you want to save in life is your time, okay, especially in the development of video games. Saving time is the most important piece that you need to always be aware of. And you need to always save it. If you don't, then you're just going to be working a lot, realizing that you could have spent, 20 hours on developing a game rather than spending a week on it. Okay? So just telling you, I'm giving a good piece of advice. Don't spend too much time on things that already has all these options to do. And Unity has done this for you. They made a cool tool and use it wisely. Okay, and I'm assuming that a lot of you guys have already made these prefabs to apply to other different levels. But if you haven't yet, that's okay. Just make the prefab of this character that you made, right? And just, drag it down here and just apply that character to each level. Okay? So let's just say I made like a level 3 here. So let's just remove this thing right now. Let's say I did not copy paste it this time. You might be asking, now, if I made a prefab, how can I apply that? How can I just paste it there? Well, remember, prefabs are like templates, so you can just literally drag and drop, and there we go, voila, we got it. It's right there in front of us, which is kind of insane if you think of it, that it's amazing how Unity spends so much time making cool stuff like this for us, and we should really, really appreciate it. Okay, so in terms, that is prefab. Prefabs are like templates that you can reuse them anytime, and it's really, really helpful. We're also going to go in the future. There's more than just prefabs. We call them nested prefabs. But we don't need to worry about that right now because nested prefabs has a lot of very confusing things to do with. And we will go more on that once we make our final CyberRide projects. So yeah, don't worry about that right now. Let's just stick with prefabs as the basic idea and move on later on with more ideas. Okay. All right. Yeah. So our prefabs like classes. Not necessarily. Classes. I think I get your context of like the logic behind that. I kind of understand that classes is like it's like a blueprint, right? Classes are storing blueprints and information and stuff, but prefabs are just like something that you could reuse them more. So I kind of get the logic that hey, you could access the scripts again anytime, but not necessarily. Class has different kind of attributes and prefabs also have different things. Don't try to relate them too much. They're not the same thing. So in a prefab, you cannot make methods and stuff and do statements. They're just like a tool that you can just drag and drop. It's like if you open Scratch, they're like pre-made stuff that they made already for you, right? So it's something like that, basically. Classes are more like just blueprints that just it allows you to make a main method and stuff. So yeah, maybe it's not really the same thing. It's really different. But yeah, they are similar in ways that you can reuse them. That is true. I hope that clarifies that for you. All right. Oops, sorry. Let's just go back. All right. So that's basically prefabs. Okay. You can reuse them. That's the idea. They're not classes where you could make your own statements and stuff within those prefabs. But it's more like yeah, it is more like a structure, a big structure of a thing. But it's not a program. Always think it's not a program. It's just a tool that you can use them always again. It's like just a brain structure. Yeah. I think I might have like maybe explained it in a very wrong way, but yeah, they're not really the same thing. They're kind of different. Yeah. Yeah. So you can see over here that yeah, like I said, anything that's in blue. This is a Unity 2017 version, so it looks kind of old. I understand with all the gradient buttons. I never liked them. But yeah, you can see that that they have dragged something down here, and that is a prefab. And let's see, yeah, that's basically it. They're like 5 game objects that they did, and what you can do is you can just drag them as many times as you want. So it's really helpful to use prefabs when you're trying to make enemies. Okay, it's one enemy sprite that you made, this type of game object, and if you want to keep on multiplying them rather than Control C Control V, and like let's say as I said, like you need to apply a change to all of them, then prefabs will help you there. Like it's like a structure. So if I think of it a lot, yeah, key. If you see, since you talked about the classes thing, it's a really good question. Yeah, they are a bit same. They're very similar, but they're not the same. You cannot say they're the same thing. They're very similar. Maybe that's a better word. They're both like structures, holding information. Um, yeah, yeah, you could think of it something like that. It's similar, but you just need to discern between them that classes are more oriented in the programming area and prefabs are oriented in the more design area, the more artistic places. So if you can discern it that way and still say that it's similar, then I think yeah, we can still say that they're both same in some sort of way. That's actually a very good question. Thank you for asking that. It's a very good thing to ask. Yeah, guys. Also, I really highly encourage if you have any questions, keep it up. Let's put it in Unity, and I will answer them. And I'll do my best to answer it because I do not want to feel like anybody's confused here. I want to make sure everything's being clarified, and yeah, we can do this together. Yeah. All right. So now let's talk about rigid bodies. Okay, we talked about it very, very briefly that it's a component, and these components can be like you can put them in game objects, and basically it becomes a different type of tool, which has different types of options and features that provided by Unity, making Unity itself like a really cool like a really cool engine for you to develop games in, because Unity has diverse amounts of all these different resources and components. That makes Unity itself an amazing engine. You can make your own unique video game. There's tons of possibilities of making different types of games, and the ideas are endless. You can run many ideas through it and it still works with all these components. Thanks to these components, your games are running really well. Okay? Now, rigid body, in a way, if you want to start off with the idea of rigid body, you should always picture yourself that because of rigid body, you're able to fall yourself down, right? So, like, let's say I have a pencil here, right? Because of rigid body, it's falling down. Always think of it that way. It's basically physics. The idea that you should see behind rigid body in your brain is always physics. It's allowing an object to react to physics, basically. Okay? So if it allows itself to detect physics basically, and it reacts that way. So if it's on top, if it's above a surface and it's on top, then it can understand that there's something detecting down there, and it will repel or it will jump off, bounce off, and that's just amazing about Unity. This is something that makes Unity amazing, that they have done a really good job in the physical area, in the physical side, the physics ideas implemented in a virtual world, which is pretty cool. So they have many cool options like forces, gravity, mass, drag, momentum. You probably heard these words in physics. F equals ma, right? So the more mass you have, the less acceleration. They have actually done this. It's pretty cool, and you could tweak around with these features on Unity, and it makes your character. You can adjust your character's physics based on how they look like. So if they're really small, then you need to make their mass really small, and in turn, they cannot jump that high, or maybe because of the place where you are. Like let's say the game is in space, then gravity should not really exist there, right? So, or if you're in Jupiter, you will be really reluctant to jumping really high compared to if you're on Earth, right? Because Jupiter has a higher gravitational field strength compared to Earth. And you can do that in Unity. You can tweak stuff with it. And I'm just going to give you like an example over here. Let's just go back to level. Let's just save this first before we go. I think it was in level 1 where I implemented the rigid body. So I think, okay, I'm not sure though. I also don't know why the camera is... Oh, okay, the camera is not looking because it's can't see it, that's all. Just pardon me, sorry. There you go. I'm just gonna put it a bit down so that you can see it. So I think, if I play this, you can see that, right? It has physics. You saw that thing repel from the ground. It bounced off. And that's happening because of the rigid body, right? So actually, let's just keep on playing the game. I'll just show you the physics itself. So let's just play it. The cool part is you can actually go back to the scene and just pull the character up. And you can see that, hey, it's falling down. For some reason, it's falling down again. It's still falling down. And it's falling down because it has this component, rigid body. Rigid body is making this thing react to physics. And essentially, this is very important when you're making games that has a lot to do with movement, a lot to do with jumping, a lot to do with action. Because physics is really important there. Without physics, it's not going to feel real. It's not going to feel like you're receiving the action. And physics actually play a good part in game development. Like, if you see Minecraft, like you don't maybe realize this, but it's because it's not really that apparent. If you play survival mode, you really have to feel like you're surviving, right? And the way they move the character, the way they jump, they have made certain levels of they planned a lot in advance to understand how much they should jump up, how much they should jump down, how much they should move forward, how much they should move back. They also adjusted the mass of the characters. I don't know if they can do that in Java, but that's kind of an idea. Let's not just apply this in Minecraft, but in games like Modern Warfare, like Call of Duty and stuff. They have worked a lot on working on each specific character that you can play in, and they have their own type of components. Okay, they have adjusted to their own type, the way they are. If someone's big, if someone's fat, if someone's so skinny, they have their own type of rigid body. Now I don't know if, I mean, I'm pretty sure that EA Sport, like EA, sorry, Call of Duty, so Activision. I'm not pretty sure. I'm pretty sure that they're not using Unity for game development. Like usually, all the game companies that are big tycoons and stuff, they would have their own game engine usually to develop these amazing games. But yeah, the idea is like rigid body. They probably have some component like that. It's probably not called rigid body, but they definitely have some tool that has with physics. Like right now, I believe the best physics, the game company that does the best physics is Rockstar Games, I believe, or maybe not given the best award. But if you play it, like if you play GTA and Red Dead Redemption, their physics is actually super super complex and amazing. They have even worked on hair physics. You'll see this later on in GDC posts on how science was done behind it. And how even on Forza, the car game, they had a lot of physics because they had to understand the drag between the ground and the tires. Okay, we're not noticing this, but this is something that game developers like you guys need to understand, that this is fascinating. How cool the world is, and not cruel. Do not say that. Do not think I just said cruel. I said cool. COOL. How cool the world is. And just you need to appreciate it, and this is how you can make games better. You need to explore the world, basically explore the things around you. Just be fascinated by everything, the physics behind it, and that's what's going to make your game even more intriguing. You'll get inspired by many things around you, and you will notice the things that not many people would really see, right? It's those really hidden information out there that not really everyone would look forward to seeing, and that is something that every game developer has. They know the stuff that not everyone can see, basically, right? You probably notice some stuff that not everyone notices, and this is something great about game developers. This is something that I want to advise you all to do, is that just explore, appreciate things around you, and that's what's going to make your game a more amazing than usual. Okay, and obviously apart from all the narrative stuff and things, that other factors do come into play, but just keep in mind, just keep yourself super curious, super fascinated by stuff around you. Don't complain, rather find solutions. That's something that I really get admired from many people talking. And yeah, that's basically rigid body. This is something that you need to know now. And I think if we go back to the slides, we can talk about something else that they have. Uh, okay, so before we talk about anything, let's talk about the rigid body 2D and rigid body, like just in general. Unity made a specific type of physics for both 2D game engine and a 3D game engine. Okay, so 2D games do not have a z-axis, right? We talked about this. According to the Cartesian coordinate system, a three-dimension looks something like this, right? We have something here, something up, and then something in another direction. And that's causing something to come out, like, in 3D manner. But in 2D, you're only dealing with two different axes, right? X and Y. And it's actually really easy for developers to make games that way. But that means they have to make an all new different physics area that they cannot they have to constrain the z-axis, because that just doesn't exist in 2D physics. And 2D physics is a bit more different if you play some games like Mario and stuff, or maybe like the newer version games of today that are 2D. Their physics is actually pretty advanced and stuff, and it's actually thanks to Unity game engine. A lot of indie dev video games that are 2D actually came from Unity. Um, and you should really appreciate it. It's amazing. And then the 3D physics actually does not constrain any axis. It has X, Y, and Z axis is not constrained at all. And that really just brings more complexity in many different coordinates, because now you're dealing with three coordinates instead of two coordinates, and you don't even need to worry about this because Unity already made a tool like this to save time from contemplating all these amazing different complex coordinates around you that does the physics for you. So you should be really appreciative of this freaking component, because that thing is what's making physics drive in video games today. All right, and again, yeah, it's gonna put an object under control of physics, right? So when you have a rigid body now, so if the one way to give an experiment to this is, hey, if I don't want to, I can just remove it right now. So I can just remove the component. If I don't have the component rigid body, right? Look just just look at what just happens now. Okay, wait. It's just staying there. It's static. Okay, my screen hasn't frozen. It's not frozen. I can just prove it to you. It's not frozen. It's just staying there. It's static because physics is not playing in the character at all. The character is not depending on physics anymore because you have not added that rigid body component. And this is something that you need to know that without rigid body, there is no physics in your game. Okay. One additional thing that rigid body does is for collision. So eventually, as we develop this 3D game, did my internet just fall off or something? Okay, I think I'm back now, so that's good. I'm just gonna continue with this thing. Yeah, so basically, what we'll do eventually in Unity game development, especially for this project in Maze, it's gonna be a very simple project, right? We're not trying to go really insane with the graphics and stuff right now. We're just trying to get in touch, like just understand Unity and get in touch with the environment, get used to everything, and then we'll be ready for making more advanced games in the future. Okay, but one thing that we'll be learning definitely is collision. So what I'm trying to say is I think I've explained this very previously, but not really in detail much. But basically, like let's say we have like one object over here, right? Like this is my sharpener, and we have another object here. This is my Apple charger. And the thing is, in real life, like when we meet these things together, they're colliding, right? They're not going through each other. Like if they're not going through, okay? I'm not doing any magic. This is just behind me, but it's not going through, right? The moment we hit each other, they're going back. They're repelling. And what rigid body does, it helps notice these kind of specific type of physics in video games, and it just helps them notice that hey, there is an object here, and we're colliding. We're not going to go through that. So if rigid body does not exist on a specific object, then it cannot detect things around them, and that causes a bug, right? Essentially, like if we go back to, let me just go back to G. Yeah, oop, that's not Unity. This is Unity. Yeah. Um, so if I like make a character here, like just for now, guys, I'm not trying to hurt your feelings, but let's say I made another character, okay? Basically, if you do not have theoretically, if you don't have any rigid body, this is just gonna go through this, okay? It's just gonna go through this poor little other character in the game. But if we did have rigid body on this character, then it will help notice that there is something around this object. And what you need to know is you only need one rigid body. So if two things are colliding, only one object needs to have a rigid body, and it will easily notice that something is colliding with the other. Because what happens usually is when you have two rigid bodies, when you have a rigid body on both of the objects in this, like let's say this has rigid body and this has rigid body, then what will happen is Unity just makes some sort of bugs for now, which is not actually nice to do. They're still fixing on it, I hope, but usually just sometimes on a rare occasion, glitches happen in your game and stuff. The character just falls out of the environment. So just keep that in mind that only one is enough. One object just needs to have a rigid body component, and that's more than enough to know that these two things will be colliding with each other. Okay, but still, that's a very complex topic to cover. We'll still talk about this very soon in a few lectures, probably in the next lecture or so, in a way, if we start talking about it. Or maybe like in two lectures, because next lecture we're talking a lot about TPP, like third person motion movement and stuff. But yeah, we're gonna very very soon get in touch with collision. So do not feel like hey we're going away from it. No, we're coming back. Okay, so yeah, that's all about rigid bodies for now. That you need to know that it's just about physics. The moment you think of rigid body, it's gonna be physics. Okay. All right. Yeah. Cool. Now we're gonna move on to our if-else statements. Okay. Uh, Again, as I said, a lot of you guys might have been used to these things now because some of you guys are taking AP Computer Science, and maybe you're in Python or maybe you're in Java. It doesn't really matter. But maybe you're just learning programming for fun, and you probably just encountered this. But we'll just go over it because it's very, very, very important when it comes to coding, especially in C# coding. Okay, basically, this is how execution flows, right? There's like some statements here, and then you get another prompt, and there's like there's a condition. I think diamonds. I'm not sure, but I think this is what we call a flowchart in computer science, basically. Anytime you encounter this, especially if you're an AP Computer Science principal student, you'll definitely encounter this. This is just like a future purpose thing. But even if you're just a comp sci dude, like you're an undergrad or graduate, you've probably seen this. We call this a flowchart, and it just helps outline your code and stuff, like how your program will flow throughout the program. And each different shapes represent something, right? I don't know what these things are, kind of forgot, but I'm pretty sure this is a conditional thing. So this thing will report something. It's like two conditions. If it's true, then it does something. If it's not true, then it does something. When I say true and not true, what I'm trying to say, if we have a condition here, like let's say, does Russell have a girlfriend? If I do have a girlfriend, then this condition passes. But if I don't have a girlfriend, which I don't, sadly, then it will just pass this thing. Okay, so there's like two different scenarios. Okay, it will not run the code. Like usually in our terms of coding in C sharp, if it does not pass that condition, then it won't run that thing. It will probably run something else, right? But if it does pass that condition, then it will run what is within that condition. And this is where if-else statements are used to organize your structure in code. And it's really used in conditions like, if the player health is less than 3, or if the player health is 0, or less than or equal to 0 for safety reasons, because if you just put 0, then you're going to cause problems in your code. Just let you know. We're going to get a bit into, just to get that we're going to also teach you a lot about debugging and how to make sure that you guys don't get bugs in your game. There are many different techniques to this. I haven't gone through all of it because I'm still an not that advanced game developer yet, but I'm still there. I'm getting there, and I'm teaching you all. Okay, so this is how you structure your kit. I'm never ever gonna ask you about these things. Okay, I'm never gonna ask you, hey, design a flowchart or thing. Don't get freaked out. I'm just gonna try to tell you that there's a way that programs are structured. It's flowing through some manner, and if else statements come into play over there as well. That's what I'm trying to talk about through these pictures here. Okay, so yeah, this is what an if else statement looks like. At least something like a structure of it, as I said over here, the structure, the formatting of it. Okay, there are basically 3 different languages that we use. My Wi-Fi just cut off again. I think I'm back now, so I think I can present. I'm not sure. Yeah, so what I was trying to... Okay, just for safety reasons, can someone just let me know if I'm back? Okay, thank God. Okay, sorry guys. Alright. Yeah, so getting back to this topic here. So there are 3 different words that you need to know in an if statement: if, else if, and else. Okay. Usually you can also change this to elif. It's just ELIF. It's just a shortened form of else if, and a lot of developers use it just to save their time, because we're lazy. Just kidding. We just want to save a lot of time. Okay. You don't want to waste our time on some stuff that just takes too long to type. I know it's a very lazy way to explain something, but that's what I'm just trying to say. Anyway, let's just explain about how if, else if, and else, how they all distinct from each other. Because they're part of if statement, but they should be different in some sort of manner, right? Okay, so if statement, usually how things are structured is you have an if, and then you have a parentheses. Within the parentheses, you put some expression, some condition that if Russell has a girlfriend, then if I have a girlfriend, anything that's within this branch of code, that will run. Okay, and if I don't, then it won't run anything that's within this branch of code. Anything within this thing. This is a comment. It's like I already commented here, but usually you would put program statements here, and I will just output this, whatever I do, if this condition is met. Else if is used that if this thing isn't met, then if this condition is met, then do this. Okay, so what I'm trying to say is the condition is 2 things. 1, that if this is not met, and 2, the condition within this parentheses here that's inside of this else if that's met as well, then you would be programming this block only. Okay, you'll be outputting anything that's within this branch of code. Else is just basically if just nothing works, like if nothing above works, that's literally the condition. If nothing above works, then just execute this. So basically, in other words, if this is true, then I would only execute this. I would not start executing these things, then these things. I would only be executing that's within if. Same for elif. If this is passed, then I would only be executing this. However, there is something that a few of us, even me sometimes, I would get confused by. And it's that, let's just go back here. It's with this type of idea that if something is passed, and if something is passed. Usually, if this is the case, then you would then it's not like, hey, the condition here is that you would basically be doing both of these conditions, all right? You'll be checking both of these conditions. So if I have not passed this, and if I have passed this, then I would obviously only be doing this portion of whatever is within Basically, what I'm trying to say is execute anything. Why did I put that S? Execute anything here. However, if it's if this is passed, right, then I would also still be performing this section of the condition, even if it's not passed or no. Okay, so this is kind of a thing here that else if is used when only this is not working, and then you would usually go there. It's very difficult to explain like in terms of words, but yes, you need to just make sure in your head that if you have something like if, that is different from if and else if. Okay, they're not the same thing. They're very different from each other, and it's very difficult to explain the distinction. All right. Let's just go back. All right, so that's actually it on if else statements. I know it's I'm going a bit off the time. We might be finishing this in around 4 o'clock. But the final thing that I want to talk about today is, as I promised, how do I now let's just remove this thing for fun now. How do I make this thing move? Like I made the game. We designed everything. I'm pretty sure for you guys, you've already designed your maze and stuff. It looks amazing. The question now is, how in the freaking world do I move this by itself using the keys that we have on the computer, right? Well, as I said, today we talked about if-else statements. We talked about other statements as well. And we also, sorry, not other statements as well. I meant like we talked about other ideas as well. But today we're going to also wrap up with, how to use components, especially how to access components like transform in our code. And I'll be going over this today right now. So let me just put this to the side over here so that I can see as a guideline for me. Okay. Anyways, let's just see. All right, let me just remove this right now. First of all, the thing is, you should always think yourself, if I'm ever gonna be wanting to move something, would I put it in the start method or would I put it in the update method? Just think for yourself for a few seconds, and then I'll give the answer. So I'm pretty sure, I hope you're not biting your nails right now, but the answer would be update. Okay, it wouldn't be start, because what happens is if I put these conditions in the start, it would only execute the moment it starts, the moment your application starts, and it only happens for once. It doesn't keep on updating itself. Right? Let's not say the word update. It doesn't keep on reusing itself. You cannot reuse that program again. And this is why you would put it in update, so that you can always access that code basically, and keep on using these key movements to move your character in the game. All right. So the first condition that we need to keep in our head is, how do we move something? Well, if you remember, we have this idea that it's input. Right, input.get key, or something like that, get key. And then if for now we don't want to be using like a WASD key, we want to be using the up down arrow keys, so the arrow keys on the sides. So basically it's actually very easy. If you just type in quotations up, it's just going to recognize that, oh, this is the up arrow in your keyboard. But that's not really it, right? We want to say that if we press this, then we would, move the character front. So we're actually missing something, which is the if statement itself. So if the condition is basically this, if I press this thing, then we want to perform the code. So we always start off with the brackets and put our code inside. Okay, so the first thing we would do is how to access basically. The question was, how do I access the transform component? Well, the way you would do that is you would start off with the word transform. Okay, the cool part about Unity is that you could access any component that is within the same game object. Okay, so in other words, if our code, what should I call it? You know what's funny? I did not add the thing to my character. So the first thing that you need to definitely do is add the component, which is our character move script. Again, that thing is going to contain our script, so it's going to be applied to everywhere. Now, what happens is if this script that we have, which we're using right now, is the character move script, we can access any other components that's within the same game objects it's in. So character move is in the character game object. So that means it can access the transform component, the rigid body component, and and Unity helped simplify this for us. Helped simplify how to call these things inside of our program. So we would just type transform dot, and then we would type translate, and this is some different function that they have within for the transform, and we want to translate the x, y, and z coordinates, right? So let's just say for now, we just do 1, 1, 1. Okay, and each different comma represents a coordinate for the object. So if I just save this, and then let this thing run. Okay, so it's compiling for a moment. My apologies. Yeah. So if I press the up arrow key now, it moved, right? I'm actually not lying right now. If I just press up arrow key, it's moving somewhere. It's translating. Now, just for now, okay, just for now, I'm just gonna remove the rigid body. Please don't cry about it. It's just because I'm kind of sick of gravity right now because it's probably gonna just, make me mad. But that's the idea, that each different coordinate is representing something. Now, if I don't want a specific coordinate to be affected, what I would do is I would just put 0 over there. Okay, now let's see what happens. So let's just save it. Let's run it. Now if I press the up arrow key, it's not going up. It's actually not. If I press, it's literally not going up as it was before. And it's because this thing, the 0, where it is right now, that represents the y coordinate. And that means that if I put 0 on the y coordinate, well, if I apply 0 amount of something to the y coordinate, I'm basically not changing it, right? Because anything plus 0 is just itself, which is in its previous state. So it's just not even, so in other words, 0 plus 0 is 0. So you wouldn't be changing this thing at all. However, we want to think which z-axis, I kind of spoiled it for you guys, I'm really sorry. But which axis do we want to affect, right? Because I know that from my basic knowledge, what you guys should know, that this is the x-axis, this is the y-axis, and this is the z-axis. We want to know, are we affecting the x-axis or the z-axis? Because when we press up arrow, that means we want to go forward, right? You don't want to go backward, you don't want to go left, right, you want to go forward. Because that's basically the concept in gaming, that it's just it's a gaming norm that we press the up arrow, that's moving forward. So if we press the character, we can see that if we access this thing that's over here, they have the red, blue, and green. Well, we know that blue represents Z, X represents red, and green represents Y. If you don't remember at all, don't worry, because I never remember that too. But you can always see it on the top right that, oh, okay, this is what each things represent. Now let's look at the camera. Okay, the camera is up over here. That's also going in this direction. So let's just think of it in this perspective. Okay, our camera is in this perspective, straight. So that means we're going forward towards the z-axis. So we need to be affecting the z-axis only, not the x-axis. So if I put 0 on the x-axis, we clearly know that we're not affecting the x-axis anymore. All right, so let's just save this. I don't know. I'm not going to bet myself, but I'm pretty sure. Yeah, now you can see, hey, it's just going forward. I'm not going left or right or down. Now you can see, obviously, it's not falling down because I have not applied rigid body to it. So thank me for not applying physics to it. You're welcome. All right. Now, what I want you to do, this is going to be one of your mini assignments, is I want you to be doing this the same thing for the down arrow, the left arrow, and the right arrow. I want that character that you made, I want it to move that way, one way to the forward, to the left, to the right. I want you to change it. Okay, I want you to do for each different thing. So what I'm trying to say, I'll just give you one spoiler over here so that you could work on the other ones. Let's say for the down arrow, we want to now transform to the back. Okay, now you need to think of it. We are still in the same axis, right? We're still in the z-axis. We're not changing the axis at all. So we're still going to be translating only the z-axis. So we keep 0 for everything else. But we're not going forward. What's the opposite of going forward? Backwards. And that's a negative value, right? If you kind of think of it in terms of logic, that if you're going backwards, that's opposite of where we're going forward. And if going forward is positive, that means going backward is negative. Okay, so I'm pretty sure that if I press the down arrow now, that I'll be going backwards. Okay, so let's just test it out. Game test it. You can see that now if I press the down arrow, I'm going back. If I press the up arrow, I'm going front. Okay, I want you guys to be doing this. Now I feel like, hey, I'm moving by a pretty large value. So this is where I'm going to teach you something very briefly. This is a very great tool, which is going to help you all. It's going to save your day someday. Is we're going to make a variable. Okay, we're going to make a variable, and let's actually not make a variable. Okay, let's actually not make a variable. This is something that I want to introduce you guys with. I am not going to explain it very fully right now, but we call it serialized field. Okay, serialized field, I'm just going to explain it to you very soon. Is that Siri? Did I just hear a Siri? Okay, that was scary. We're going to make it a float value. We need to give a primitive type. Anytime we're trying to make a variable, we need to give some sort of type to it. This data type is a float, and we want to call it maybe move speed. Maybe like this is the amount of amount we want to give to translating some specific axis, and you can just give it some constant value for now. Okay, now don't yell at me. I'll just show you. I'll show you the magic. Calm down. All right. Now if we click on the character which we applied it to, we can say, whoa. Do you see that right now? We see move speed and we see a value there. This means that you can actually, when you play this game, you can just manually play test the amount you want. And this is going to be super, super important. Now, before I do anything, I forgot one very important part, okay? Which was, I forgot to add this. I forgot to replace 1 with move speed. Because if I do not replace that with move speed, it's not going to affect anything. It's just still going to affect by 1 always. So if I still change the value of move speed, it's going to do nothing. Okay, so make sure you apply it there. But let's just play the game for real now. Okay, now, oops, let's just click on it. Oh, okay, now we can see, oh, it's a very fast. Now let's actually change it to, I don't know, 0.01. I'm regretting my life right now. Yeah, you can see that. You can see that you can see that very clearly. It's moving very, very slow. But you can actually just play around with the values and stuff. Keep on playing with the values and stuff, and you'll get the right amount. And the cool part, and this is something I want to talk to you. When you stop playing your game, right? When you click on this button, it'll reset to its original state. So what I want to do here is just change it to that value. Okay, and this is something that Unity is not doing a great job in. Sadly, they did not try to find a way to make this a better thing. But whenever you stop playing your game, it just resets to its original value. Just keep that in mind, because you might lose a lot of data for doing it. Okay, so only play the game for playtesting, and that does not guarantee saving it to that state. Okay, and now I think if I play it for real now, again, now we can see now it's at 0.71. Right, so it's pretty cool. So it doesn't matter, even if I put number 5 over here, I can change the value with the concept of serialized field. So now just briefly, I'm not going to explain too much about serialized field, but what serialized field does is it can become like a feature, an option on the screen on Unity, which becomes a really versatile tool, because now you can make your own type of tools inside of your own script, which is amazing. This is something that Scratch does not offer. This is something that Pygame does not offer. I swear to God, if you like Pygame, I don't know what you're doing with your life, because I don't know. Just don't do that, please. But this is something Unity does a great job in, and I really appreciate it. And this is I wanted to talk about for this entire lecture. That I wanted to talk about how to mod things together, add movement to your character, and also access components inside of your script, because that will be super, super helpful. And also a bit about serialized field, that concept. Okay, let me just open my intermission screen. Okay, guys. So today I wrapped up a lot about these things. It's a huge concept. It's pretty long. I'm really sorry about that. But yeah, that's basically it for this session. Before I end this meeting, I want to talk about a few things. One being that some assignments that I want to do in your own, that you should be doing in your own free time, is one, try to complete that code. Try to complete the left side for the key, the left key, and the right key. Try moving it left and right using some concepts. And other homework is try to keep yourself boosting yourself up. Try boosting yourself up in the Me6 level server. And do your best. And on October 15, I'll be guaranteeing that first place winner will be getting a free Discord Nitro for 1 month. All right, and I'll be announcing if there are any other more assignments, but maybe just keep on working on your designs and stuff in your own game. If you encounter any problems, just feel free to reach out on the Unity channel. Anybody's willing to help. And actually, the more you help, you actually get a higher chance of earning more XP because you type more. But yeah, I just want us to be an amazing community because anybody should be helping each other, and it feels really great to help each other and stuff. And game development's not easy. You need to keep on doing teamwork. But yeah, if you're ever also lost, use the Unity documentation. It helps you a lot. Um, so yeah, actually, I wanted to talk about Unity documentation for a bit. You guys were like maybe confused about. Oops, let me just talk about. You might have been confused about transform. Like, how in the world would I know that this specific code that I added in character move? How do I know that it's transform? Like, I don't know if it's capital T or lowercase t. How in the world would I know that? Well, you know that if you go to the Unity documentation. So you can type on Google and just type the transform component, how to call it, and you're literally going to get a code on this, and they'll explain everything really, really well in their own Unity documentation. By the way, if you heard the new news, Unity has also changed their own logo. You can share your thoughts about it on the channel as well. So I'll be announcing if there are any more assignments regarding game development. I'll just share it, but it's due next week. So just keep on working more diligently. Next we will be working more on the TPP movement and the camera movement, and probably, hopefully, try to do more with the variables and stuff. Hopefully, maybe introduce new concepts on prefabs and also rigid body and collisions and stuff. But yeah, that's it for today's session. I hope you really enjoyed watching this content, and I'll catch you later next week. So stay creative, guys.